Hello everyone, welcome to a new tutorial presented by the SCHalTB. Today we are going to see functions with an indirect method of inheritance. We have already seen functions with a direct method of inheritance where we directly send the value of variables into the functions. Now we are going to see functions with an indirect method of inheritance where we are instead going to send the location of the variables into the function. We send the location of variables or the address of the variable into the function, and the function receives that address with a pointer, similarly to a person who is given the address of a room of a hostel. The hostel manager sends him the address of the room, and the person who is going to go use the room is going to receive the address and being pointed toward the room. So that's how it is. So we see the first thing again to functions. Whether you do a function, anytime you note that you have to do a function above the main function, there is no need for you to put a prototype. But I like that as a habit, we always place a prototype above. So we tell our compiler that we are going to have a prototype of a function. Let's say the function will now be the area of a circle. So here we have void. We first create a function of data type void. The name of the function will be area circle. So we have this function area circle. Now into it we are going to place the value of the radius. The value of the radius, let's say, is going to be a float. Now we know that here we are to receive the value of the address now by a pointer. So now instead of placing a float of a, we are going to place a float of pointer of a. We are going to place inside the main function the address of a variable, and now we are going to receive that address by a pointer of another variable, so that this pointer should be equals to the number. So now we continue by doing float the next number. So here we know that inside the area of the circle we just need one number, float address of a. So let's say we still have to do an addition, because we are not going to receive two numbers. So let's say we are going to have, we are still going to have area of circle, Now in this area circle, my float a, I'm going to send the value of pi, which is a constant, and float b, I'm going to send the value of the radius, this. Now here I'm going to directly introduce constants. We need to know that there are two methods of declaring constants. The first method of declaring constant is by using this. To say define, you place the constant name, let's say pi, and you place directly the value of the constant 3 without assignment, 3.14 example as such. If I want to declare the constant, this constant, I'm just going to write here up above the different functions. So I place it as such, define, I place in the name pi, and I place directly the value 3.14. So this is one method of assignation, so I don't have to place a semicolon here. So this is my first method of declaring constant. My second method of declaring constant is by using the word const inside my functions. I use the word const inside my functions, and then I use my data type. Let's say it's going to be float, and I use the constant name pi. Let's say it's pi. So my constant name will be pi. So const float pi now equals to 3.14. So this is how I'm going to declare a function, a constant inside function. Now this first method of declaration is going to be used by all the functions. It's going to be used by area circle function, it's going to be used by the int main function, and all of them are going to see that this value pi is going to be a constant. But when I use constants only inside the main function, you have to note that it is only considered constant in the main function, because when I'm going to send this into the area function, this constant will not be a constant but a variable whose value can easily be changed. So this pi can easily change as any sort when you send it as constant from the main function. But now for our case, we are sorting function indirect method of inheritance. So I'm not going to use this first method, I'm going to use the second method for us to see how to inherit the value of pi we have placed as constant inside the main function into the area circle function. So I'm going to cancel all this and use insert this method. Though this method is not visualized as constant in the area function, in area circle, but we are capable of doing this to be a constant in the area circle, as we are going to see later. So you first declare the prototype of the function as such. Void area circle float, I receive it as a pointer, and then I receive the second value as a pointer. Now we continue. We have the int main function. The int main function, we continue as such. We say int radius. This is a radius, and this is a declaration. We say the radius, let's say we say the radius equals to 40 or 31.1. But now we should not place it as an int, because here we said that it's going to be float, so the values that you are going to receive are going to be floats. So we have float here, float radius. It's nice when you want to send one value into the as a parameter of a function, you should make sure that their variables, the data type of the variable must be the same. So you have this. You are going to see, you are going to have also another value. You are going to place the constant float pi. This constant float pi is going to be the second value which is going to be sent. The first value which is going to be sent, or let's say the first value which is going to be sent, is going to be constant pi. Good. And we paste here. The first value we are going to send is going to be the constant pi into the pointer of A, and the second value we are going to send will be the float of radius. So we have this is 3.14. Now the next thing to do is now, where are you going to send this value? So let's first go to our function void. So let's create our void function. So we have a void here. We are going to have void function. The function is called area circle. Then we press that, enter into it. We have float of the first one is the pointer of A, and we have float second one is the pointer of B. We come out of it, we enter now into our function proper. When we enter into our function proper, we are going to say that because we initially said that in pointers, this pointer of A will be the variable of pi and radius when we are going to compare it to the address. So now what happened is that we have this pointer and we have pointer of B. We initially said that if you have this line where we said pointer of A equals to the address of a certain number, this line indirectly means that we are going to say that A is equals to the address of the number, and the pointer of A is equals to the variable number. That is a similar thing that's going to enter here, because you are going to send the address of number into this pointer of A. So this will be the address of number, and the pointer will be actually the variable. So when you are going to perform actions here with the pointer of A, let's see, we know that we should have the area of circle, so we are going to declare another function, another variable here, which is going to be called area. So which is going to be called area, that this is a variable. Now when we have this area, the area will be equals to, I do pi, no, it's not pi, because here in this case I'm sending the value of pi from in main function into the void. So the first value I'm going to send will be the value of pi. So now the value of pi will be, I place it now into bracket, this, the pointer of a. So this is the pointer of a times, I place again into a bracket. This will be will contain a pointer, the radius. So I place into pointer of b. I do again times, I place it into bracket, pointer of b again, because still contain the radius. So it's pi times radius times radius. So I come out, and now do a printf, because the void is not returning the value. Printf, I say the value of the area is, the value of the area is, so I need to remove this. I need to place inside this, and I place this. The value of the area is, put my 2, I come out, and now say that this is going to be, I place as an int, but it's supposed to be placed as a float, because the values are containing floating values. Yeah, radius and pi are both floating values. So I'll send it out as a floating number, then comma, I send the value of area out as such. Yeah, I want it to be on the next line, and I tab it, so like this. So the value of area is this. So let's come back into our printf. So what is going to happen here is that I'm going to call now this function from my in main function. So I'll say here that area circle will be equals to, I place now inside it, I'm going to place the address of pi. So what happened is that I place the address of pi, and I also place the address of radius as such. So I have the address of pi and address of radius. So what happened is that the first variable is going to enter into the address, into the pointer of a, and the second value, the second address, is going to enter into the pointer of b, and it's going to do this. This of a equals to address of number, so it implies that this will be equal to actually pi. So this of a, the point of a, will actually be equals to pi, and the point of b actually equals to radius. So here are going to be the values. But now I initially told you that this is a constant, code pi will be a constant inside the in main function, because the main function and the area function are not considering variables the same way. So this value here, point of a, will contain pi, but it will not be a constant. So in order to place it a constant, you need to say that this is a constant inside the function. So let's see. When you have this, I cancel my initial program, then I compile and I build. Error comes here. Printf, because of the big F. Come back. I compile and then I build. I have this value, pi times pi equals to, this is the answer here. The answer is this, is correct. Now I need to know that I am capable of changing the value of this. A constant is not supposed to change a value, else you are going to see an error. Example, if I change here, I do pi equals to, I've already declared above here that pi is equals to 3.14. Now I declared down that pi is equals to 4.5. Let's say 4.4. I have this. If I declare this, I run the program, I'll see an error as such. assignment read only variable pi. Here it's telling me that I've said that pi is a constant, and how is it possible that I said again that pi is equals to 4.4. I change the value of pi anytime. The compiler says false, it cannot be true, so you should not change the value of pi. But here, if I change the value that I received here as this of a, now because this is the one that received pi, I change it now to 4.5. So if I change it to 4.5, I see that it's going to compile this of a, so it's also taking as a compile as this. It's not capable of changing. So when you compile all this, we are going to run and build, and you are going to have the value. But to be on the safe side, you can also consider that this is a constant. You can declare here as a constant here in order for us to be on the safe side, so that when it receives the value of pi, it also enters here and to be a constant. So you have to do this. When you declare it as constant here, you enter in the value of pi and declare as constant, and you build and run. So it tells us that's an error because I didn't declare also here as being a constant. So you do that, you build and run, and you run. So the value will be this. Else, when I receive it into my value of a, I can easily change it from one point to another. Now the next thing is if I use now instead an int, a float type. A float type here will also be a float type. Now if I use a float type of a function, now I know that I have to return a value. So the first method, I can return it, and I do by the direct method and directly place it into my loop as such. So I come up, I remove all this, I cut here, so now it's going to return a value. I remove also this, I know that this is going to the area, so I cancel also this, and I place this one here, paste. Now I'm going to remove this. So now I know that with a float, when I have a float type, it's going to return a value. So let's say it returns area, this area here, as seen, it's going to return area here. Now this area here, when it's returned, you can directly call it into your function. So that's the direct method of assigning the value of function into the main function. So when you want directly to call the value of the function area circle into the main function, you use this. As you have already seen initially, area, you place directly in the values of, you place the address of the different values. Here you are going to place the address of pi, and you are going to place also the address of radius. So when you do that, you compile. So this tells you an error. Undefined reference area. So this is insert area circle because it's a function. The function here is area circle. Place it into address of pi and address of that. So you have this. You build. We are going to have the value. This is a direct method of sending the return value from the function into the main program. Now, if I want now to change the value of the area circle now in the main function, so I'll need to assign this area circle now to another variable into the main. For me to assign this return value of the area circle to a variable in the main, I need to use pointers again. So let's see. I'll consider another floating number which is going to receive the function as a pointer. So that floating number, I'm going to call it a pointer of area 1 as such. So when I do this, I remove this because I want to use the indirect method. So I have the pointer of area 1 and now down here I'm going to declare these functions as being pointers. Now, as being pointers. So when I declare this function as being pointers, I now say area 1 is going to be equals to the area circle into the address, and I'll place the address of pi, comma, and I place the address of radius. So I'll place now this into this. So when I have this, I compile. So it shows me this error. So this is method 1. Now, what I need to put in mind is that because of the printf token, the error is because of this. I need to put this semicolon, then I compile, I build. They say error expected before this. So the problem comes because I didn't place this here. So I'm going to place now area 1 here to be called. I'm going to call area 1 because I contain first the value of area 1 into this area variable. I will contain the value of the return value of the function into area 1 variable, and then I send it out. So I compile. The problem comes here now. The problem comes on the return value here. The thing to put in mind is that I'm going to give you some points to note in order for you to use pointers and how to return the value of functions. First thing to put in mind is that if you want to return the value of the function, you must first place the address of that value of that function, of the return value of the function. Now, the return value of the function is going to come out as a pointer of the address. So the next thing I'm going to do is to remove this pointer here. When I remove this pointer here, I'm going to assign that this is going to be a pointer of the address of the variable function, and here I'm going to come out with the area 1. I compare here and I have no error, and then I build. My answer will be exactly the same as such. So what happens here is that when I compile, I see one message warning function return address local variable. So normally I'm supposed to return this address, and when I return this address, it's going to enter into a pointer. Now, before continuing, I'm going to tell you something which is very important. We initially said that if we have a pointer of p equals to the address of a number. Now, if you have this statement, it indirectly means that the pointer of p will be equals to the variable number. Pointer of p is equals to the variable number, and it also means that p is equals to the address of number. Now, if we add up this equation with this equation by placing some values, let's say we said pointer of p equals to number. Now, if we add up these two equations, I place now p, which is address of number, into this. I'm going to have it is going to imply that the pointer of the address of number will be equals to the variable number. That's it. So pointer of address of number will be equals to variable number. So this statement is a crucial statement when you want to use pointers. The pointers of address of number is equals to the variable number. This statement is what I use here. You see that I return the address of the variable area into as a pointer of area circle. So I return this value of a pointer into this. So it implies that I'm going to have the address of area into a pointer. So inside my function, my in main, when I have this pointer of the address of the area, I'm going to insert it now as a number. So area 1 is going to contain the variable area that has been stored here. So when I do this, I now send out the value as such. But it could be seen that C does not recognize this because it always tells you warnings. It does not recognize it very well. So if you want to do this comparison, I advise you to go to Dev C++ or to use C++ when you want to compile this, as you are going to see in our later tutorials. Thanks for your kind attention.